Today we are taking a look at scientific notation, which, if you remember scientific notation, it also involves exponents. It says scientific notation is a way to write numbers in the form a times 10 to the n. Okay, a here always has to be greater than or equal to 1, but less than 10. This will always be times a base of 10 number, and n can be any exponent. Example 1 is just simply recognizing, is it in scientific notation, and explain. Well, here's your a. We said a has to be between 1 and 10. This is not, so this is no. And it says to explain, so it's no, because 56.29 is greater than 10. If that's not between 1 and 10, then it's not in scientific notation. Again, if I look here, it's no, because that's smaller than 1. So no, because 0.84 is less than 1, and it has to either be greater than or equal to 1 in order to be in scientific notation. If I look at this last one, this is between 1 and 10. It is times something to the 10th, the base of 10. So this one would be yes. 6.1 is between 1 and 10, and it is times 10 to the n. Now we're going to look, and we're going to look at numbers that are written in standard form, and it's your turn now to write them in scientific notation. So basically you need to move this decimal so that it makes this number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7. So I moved it 7 positions. If I move it 7 positions, the number is now 5.69. It's going to be times 10, and I moved it 7 spots. So it's times 10 to the 7th. It's a positive exponent because this number is larger than 1. If it's less than 1, like our next example, our exponent's going to be negative. So if I move this decimal, I move it 1, 2, 3 spots to get this between 1 and 10, 9.85 times 10, and this is negative 3 because that number was originally smaller than 1. Example 3 is writing a number in standard notation, so this time we're moving the other way. A positive 6 here means I need to move to the right 6, so it was 1.55, and I'm going to move it 6 places to the right. 1, 2, 3, 4, 5, 6. Any spaces that didn't have digits, I put in zeros. So I have 4 zeros. And then you need to go and put your commas where they belong in order to have it written correctly in standard notation. And this is talking about the temperature at the sun's core in kelvins. So then I could put K for kelvins. B then has a negative exponent, which means I need to be moving it to the left. So it started here and I need to move it 11 places. 5, 6, 7, 8, 9, 10, 11. So this would have 10 zeros. And again, it's in Kelvin. It's talking about the lowest temperature recorded ever in a lab. Now we have some numbers that we want to put in order. Some of them are written in scientific notation and others are not. So what I'm going to do is I'm going to write what they would be in standard notation. So I need to move this 7 to the right. So I'd move it 1, 2, 3, and add 4 more zeros to get to the 7 that I need. Whoa, I'm not sure how that even happened. Kind of crazy looking. So if I double check, I moved it 1, 2, 3, 4, 5, 6, 7. So I do have it correct. So this number right here is 520,000. My next number, 5.12 times 10 to the 5th, I need to move it 5 places. So there's 1, 2, 3, 4, 5 places. 1, 2, 3, 4, 5 spots. That gives me 512,000. This next one is just times 10, so I only need to move it one spot, so that gives me 532. And then my last number here is simply 534. And it wants me to write them in order from least to greatest, and I do that using the original numbers. So my smallest number here is 532, so originally that was written as 53.2 times 10. I'm going to mark it out because I used that one. My next smallest would be 534. My next smallest would be 5.12 times 10 to the 5th. And then my largest number, 0.052 times 10 to the 7th. And that is in order from least to greatest, writing it in the original number form for my list. Now we're going to be multiplying numbers in scientific notation. If we look here, we would do 7 times 4, which is 28, times 10 to the 5th. And if we want it to, we're going to write it back in scientific notation. This one currently is not in scientific notation because this is greater than 10. So that means I need to move my decimal 1 over. So to undo this, I would have to move, originally I was only supposed to move it 5 times. Well, since I moved it one more time, to undo this, I would have to move it 6 times. So my final answer would be 2.8 times 10 to the 6th. On this one, 0.5 times 1.2 gives me 0.6 times 10 to the negative 3rd. Again, I have to get this between 1 and 10, so I'm going to move it over to the right one. So I need to subtract 1 from my exponent. So I get 10 to the negative 4. If I double check it, if I move it 4 spots, I'd add 3 zeros. Up here, if I move it 3 spots, I'd add 2 more zeros, and they'd both be the same number. Okay, you now have your quick checks to complete, and then check your schedule to find out your assignment for this section.